Hello, good evening, and welcome everybody. This is Obi-Wan Pez for N-Simplex Pachinko. Happy New Year. This is the first time that we've all kind of gathered here. Sorry, one second, forgot the door. Alright, here we go. So, hope everybody's having a good day. I'm on the wrong set. Lovely. One second. Out here. There we go. Alright, so, for tonight. Apologies for the lighting change. This is kind of unexpected and weird, but my spouse is doing some interviews for part of her job, so she needs the lighting to be good from her angle. And I forgot to move the light back. It's fine. Anyway, hope everybody's having a good one. Tonight I was digging through some old stuff. My kids are both in Scouts, and they are handing out the Pinewood Derby cars, and I was like, God, do I still have mine? So I was digging through some old stuff and didn't find the cars. My parents probably have them, if at all. Most likely been thrown out. But I did find some interesting. Did find an interesting little piece of memorabilia that I completely forgot about. Well, I didn't completely forget about it, but it has been about 19-ish years, coming up on 20th anniversary of this thing. So, so I'm in college. Story time. And I come across my whiteboard, walk back to my room. I'm the RA on this particular floor, and something is stuck in my whiteboard, and I'm like, that's a little weird. And it's like a business card. It's just kind of stuck into the side of my whiteboard. I have no idea what it is. It says on it, decipher not. And so I looked on the back, and there was a phone number and an IP address. I was like, sure, why not? I'm using the school's Wi-Fi, or the school's wasn't Wi-Fi at the time. Using the school's internet, and it can't be that bad, right? So I call the phone number from my phone, and it says like, go to a certain website or go see the website at whatever. I'm like, all right. So I go to the IP address that's here, and it links to a film which has in it a somewhat well-known-ish actor who was just starting his career at the time, named Clive Anderson. Wait, let me make sure that's right. Don't want to be completely wrong. Because that'd be Clive... Oh my god. Clive Owen, yeah. So, Clive Anderson is I think the guy from Whose Line. Yes, he was the guy from Whose Line Is It Anyway? That's definitely the wrong guy. Um, so a fairly, small-time, sort of well-known-ish actor, Clive Owen, and the film ended up being like he's driving a BMW, and then a car pulls up alongside of him, and it's got guys who are like got ski masks pulled down over their face, and he's like, well, that's a little weird. And then the back door opens, and a guy comes out with a gigantic machine gun. And the guy he's driving in the back seat throws his hands up and is like, And he says, "What's in the case?" And the guy's like, and so it turns out that the guy in the back seat has got a load of diamonds, but they wouldn't let him, just waltz through customs with diamonds, of course, because I guess, I don't know, didn't want him to get stolen, or maybe they are stolen. I don't know. And so he says, like, look, these guys are gonna kill me, so help. And he's like, all right, hang on. So big car chase, lots of gunfire, all sorts of stuff like that. They end up making the other car crash. It's all a setup for the new Z4 Roadster. So, um, actually, at that time, it might have been Z. Yeah, okay. So it's the new Z4 Roadsters coming out. So it's like, oh, okay, it's an advertisement. But at the same time, there was a little like thing that you could click, and when I clicked that, it was like a hand shot, basically, you know, really crappy handheld video cam footage of a kid walking through the streets of probably New York and coming across the car in question, um, one of BMWs. It was like i3 or something. Anyway, one of the cars in question, and it's got bullet holes all through it and stuff like that. And he kind of, touches the car's hood and like, wow, and ends up jimmying the lock, breaking in, and starts rooting around in some stuff. Finds a piece of paper, holds it up like this, and the camera behind him catches a phone number on it, and then he puts it back down, and then a guy, some heavy, comes, grabs him out of the car and says like, what are you doing? Get lost. And that's the end of the extra video. Well, when you call the number, it gives you another website to go to, and you go to the website and it gives you more instructions, and you do all sorts of other stuff. Finally, you get a key, which is some sort of alphanumeric thing. The first one was just online, and then you're in the hunt. So you get to do a bunch of other stuff. You eventually get, it says send a self-addressed stamped envelope to some address in like Minnesota. And after I did that, I ended up getting another key back with a thing on the inside that said like, keep this serial number. And so when you when you plug this into the website, it got you another step closer. You had to have 6 keys in total in order to finish the hunt. And then at the end of the hunt, I can't remember what I did with this serial number. I must have plugged it in somewhere, or it was like part of a phone number or something like that. But either way, let's see. Yeah, it's 7 digits, so it might have been a phone number. It says serial number, but you never know. So at some point, it kind of validates the fact that you physically got something from them. And eventually, anyway, got all 6 of the things done. And it said, congratulations, you're now in the running for a grand prize of a Z4 Roadster. I was like, okay. And they were having a gathering in Vegas on like, I don't know, January. It was pretty close to now-ish, right around New Year's in Las Vegas, 2003. So I was unable to go to that, being a poor college student. And I was like, great, if I win the car, I'm just going to have to immediately sell it just to pay for taxes. I did not win the car. However, I did get an affidavit in the mail that was like, hey, so you've won a prize that's above $700, so therefore you need to sign away all this stuff. Like, oh, interesting. So as it turns out, I ended up winning the second or the first prize, which was not the grand prize of the car, but the first prize was a BMW Q3S mountain bike, which I think I paid $20 in taxes to the state of New Hampshire or something like that, and then ended up riding it around. I still have it in my basement. It's pretty amusing. Um, it's rusted to hell at this point, and goodness knows it was not a very comfortable bike, but it got me places, and it's lasted this long. It was a fun little, interesting turn of events, I guess. Who am I kidding? Anyway, I'm not starting on this. So, um, yeah, that's a random little story. Things that happened to me. My father's one of these people who, like, all sorts of weird things kind of happen, and no matter what he does, whenever he is, no matter what he does when he's like trying to win a contest, I swear he always walks away with something. So one of the ways that he does it, I found out he slightly cheats, but it's technically allowed as long as you are allowed to touch your physical tickets. Um, so I didn't really find out like why this works or anything until much later. Uh, he didn't really. He sort of understood it, but basically, if you have a lottery ticket, and again, you're allowed to touch your ticket when you get it. All right, you have a piece of paper like this. It's nice and flat-ish. So what he would do is take the ticket and do this accordion fold back and forth. Now, some people who do drawings do occasionally look at this and be like, yeah, no, you can't do that. But you never know. Anyway, what he did was he made this accordion fold, and he'd kind of like wear it down a little bit, so give it a little twist, pound it around a little bit in his fingers, let it absorb some of the oil from his fingers, and then he'd come back and drop it in, and mostly straighten it out, make it look like this. So I didn't find out until much later, one, everywhere that you've creased, if you really make a hard crease, like doing origami sort of stuff, really press down on it, it makes a slight easier hold, essentially, for your finger to grab onto, and then all of your, the person who's drawing out of the bucket will be able to find this a little bit easier than other tickets. They don't do it on purpose, of course, but they tend to slip against this one or grab against this one and the others slip out of their hand, at least more often. And also it gives it a little bit, although it has the same technical surface area, it also takes up a little bit more volume within the 3D space. So naturally, if you're just grabbing in to grab a handful of stuff, you have a slight advantage on something that looks like this versus something that is completely flat. Anyway, so this is typically how my father walks away from drawings, random ticket drawings with, again, some sort of prize. It doesn't have to be anything really big or fancy, but almost every single time he won something in general, whether that be a $5 gift card or all the way up to like, I don't know. One of them he was like in the running to get a trip, to like win a trip to Colorado or something like that. Keep in mind we're living in New Hampshire, so it's a decent trip. We do skiing, so it seems like a reasonable sort of thing we might do, but a trip like that's far too expensive for, two adults, two kids, and to just do on a whim. So he was in the running for one of those through one of these tickets in, and ended up winning in the drawing that came before it. So, oh well. All right. I was watching a YouTube clip earlier today by Black Pen Red Pen. Um, and he came across, or he listed out what he did for his last question on his Calculus 2 final exam, which I looked at and was like, okay, maybe I could get into this. I sent it to the coordinators to say, okay, do we do this or do we explicitly not do this because it seems really cruel? But um, so his question was, what is the find the derivative of f of x equals, no, you went the other way. The hyperbolic cosine function at x equals 4. That's part A. Part B was find, okay, give credit where credit is due here. Find the integral of the hyperbolic sine function from 0 to 4 it might have still been the hyperbolic cosine, probably. Of course, now I'm going to have to actually look it up. Damn.
Brilliant helps you see.
Curses. Hashtag not sponsored. Yeah, it was the cosine. All right. find the integral of the hyperbolic cosine of x from 0 to 4, or find the area under the curve. However you want to word this. From from x equals 0 to x equals 4 on the hyperbolic cosine function. All right, and then the third one was find the arc length of f of x equals hyperbolic cosine of x on the interval x goes from 0 to 4. So, all the same stuff, right? So, figure out what's the value of the derivative at x equals 4, what's the area under the curve from x equals 0 to x equals 4, and find the arc length of the same function from x equals 0 to x equals 4. So naturally, find the derivative of f of x equals cosine, hyperbolic cosine of x at x equals 4. They're going to find, okay, dy dx is equal to d dx of cool. All right, take d dx of hyperbolic cosine function, which if you, it's probably just easier to do it out at the moment, but it's going to be e to the x plus e to the negative x all over 2. Better be right about that. Yeah, plus. Okay, which is equal to, well, the 1/2 is going to stay there, so it's just all over 2 anyway. E to the x is the same, and derivative of e to the negative x is negative e to the negative x, which is literally just the hyperbolic sine function of x. So then when we want to take this at x equals 4, dy dx, where x equals 4 is going to be hyperbolic sine of 4, or e to the 4 minus e to the negative 4 all over 2. Not that you necessarily need it, but, you know, just in case you feel like it. And, right, hyperbolic sine of 4. There it is. Math. Nope. Of course, I have no idea what actual group this is in. All right, catalog. S for sine. All right, here we go. Hyperbolic sine of 4 is going to be equal to, or approximately equal to, 27.28999172. Plenty more stuff after it. Okay. So find the area under the curve, take the integral of cosine, hyperbolic cosine of x dx from 0 to 4, and we end up with the integral of e to the x plus e to the negative x all over 2 dx. Again, here we can set this so that We have a 1/2 on the outside. This is e to the x plus e to the negative x dx from 0 to 4. And here when we take the integral of e to the x, we just get e to the x. Should not be that surprising, right? So e to the x. And then here we need a negative out front in order to absorb up with the negative to be part of our du if you're going that way. So we get a e to the negative x dx is going to be a negative e to the negative x. And half that. Which again, looks awfully familiar. X is going to go from 0 to 4. So we get e to the 4 minus e to the negative 4 all over 2 minus e to the 0 minus e to the negative 0 all over 2. Well, this thing's just 0, so don't have to worry about that. And then this one over here is, again, the hyperbolic sine of 4, or then approximately 27.2899172. Okay, find the arc length of f of x is equal to the hyperbolic cosine on x going from 0 to 4. Ends up being L is equal to, from 0 to 4, the square root of 1 plus the derivative squared of hyperbolic cosine. We already found that out over here was hyperbolic sine. Oops. Dx squared. Okay, and the integral of, well, hang on. 1 plus the hyperbolic sine squared. I know what I'd like that to be, but just to check. We probably have all these trig identities somewhere. Right, okay. So the hyperbolic cosine of x minus the hyperbolic sine of x, because this is a hyperbola, it's the difference between these two values that is equal to a constant, in this case 1. Oops, sorry, squared. That's kind of important. A little bit. Alright, so the hyperbolic cosine squared is equal to 1 plus hyperbolic sine squared. Oops. Hyperbolic. Of x. So with that, L is equal to the integral from 0 to 4, square root 1 plus sine squared, or hyperbolic sine squared, is the hyperbolic cosine squared. The hyperbolic cosine squared square rooted is going to be the hyperbolic sine of x dx from 0 to 4. And, oops. Okay. Hyperbolic sine in the positive region, so from 0 to 4, will be greater than or equal to 0 when x is on the interval from 0 to 4. Okay, could be sharper. That's not what I meant. Alright, this is... See, this is why I need people here. They can contradict me when I'm actually wrong. Alright, hyperbolic cosine. Which still has the same properties, by the way, so... Hyperbolic cosine is still going to be positive or 0 when x is on the interval 0 to 4. And in fact, it is greater than or equal to 1. So we're okay with just saying greater than or equal to 0 because that just means that we don't need the absolute value. All right, with that, taking the integral of an inverse, of a hyperbolic cosine function is going to end up getting us a hyperbolic sine function. Evaluated from 0 to 4. I guess you could probably see where this is going. All right, hyperbolic sine at 4 minus the hyperbolic sine at 0. Hyperbolic sine at 0 is 0, so that's gone. And then we just get the hyperbolic sine of 4, which again is going to be approximately 27.2899172. Mesahide, how you doing? Good evening. So, this was his idea of perhaps a cruel joke at the end of the long school year and Calc 2 class. Decided to give them a very simple function in order to take, again, derivatives and integrals to make sure they know what they're talking about. And then it just so happens that all of the properties he wanted them to find ended up coming out with the exact same number. So again, the hyperbolic sine of 4, or 27.2899172. It's up there. Black pen, red pen. So he did a YouTube video on his final question on his final exam in a Calc 2 class. I sent this video to my Calc 2 team and was like, so are we doing this because it's awesome, or are we not doing it because it's really cruel? Half the comments are like, if I got this, I'd be so panicked. Because a lot of students, when they see that you get the exact same answer for all three of them, would panic. If they don't like 100% know that their calculus is 100% right the entire way through, be like, I must have done something wrong. Or you do multiple choice. Make them always the exact same letter going down. Again, students be like, I got 3 C's in a row. How's that possible? It's supposed to be random. Well, yes, but you probably know what you're doing, sort of. Mostly. Or completely. So, How's your new year? Just went back to work for the first time today on Wednesday. uh, this whole week has been filled with um, days off for my kids. So it's been like, well, I'm not going to work, I guess, if you're not going to school. I'm not teaching over the winter, so that's my main reason why. I don't know about funnier, but certainly crueler. I know that I've certainly before made a mistake in class, screwed it up completely, halted, basically looked at the class and been like, "Welp, we can't go any further." Oh well. Let's see. Do I have the emojis for that? I think I still have. No, maybe not. Nope. Maybe the other one. Yep. Here we go. And there we go. Yeah, it was just one of those, oh, too bad sort of things. Uh, not much you can really do in that exact moment of absolute panic when you're standing in front of the entire class and like, well, but that was the one I think I said here I got a couple of academic complaints because I screwed up. They were like, "How dare you give us a new teacher?" Ugh. My boss was just like, "Whatever. Don't worry about it. Fix it. Don't do it again." So the next semester I did it yet again. I forgot to change my notes on that one particular thing, and I was like, I got halfway through it that time and went, "Oh no, this is the one I messed up." But I definitely on the unit exam said like, "How would you fix this in order to make it work?" And they were like, oh, "You jerk!" I'm like, "Hey, it's perfectly valid, and it really tells whether or not you were paying attention." Hmm. Probably have that somewhere. Of course, I don't know where. Could be in my other notebook entirely. One of them I probably pulped at this point. But anyway, yeah, one of the things that I just like about the hyperbolic functions is like you could do so much with taking derivatives and integrals of these things. You don't have to always go in for like the you don't have to worry too much about like how different it is from normal trig functions. Because when you're doing e to the x plus e to the negative x all over 2, you want to take the derivative. Oh well, e to the x is the same, the constant's the same, the only thing that's different is e to the negative x. It's going to be e to the x minus e to the negative x all over 2. So this is the ddx of the hyperbolic cosine ends up getting us the hyperbolic sine function. So like, oh, it's basically the same as regular trig functions. The only difference is that it's not a negative sine. It's a positive hyperbolic cosine. Right, and again, the Pythagorean identity is different, which I wrote up there. Cosine, nope. Hyperbolic cosine squared minus hyperbolic sine squared is equal to 1. So, if you know what a hyperbola is compared to a parabola or compared to a circle, this actually is pretty trivial, but you know, most of our students haven't even taken conic sections yet, which is something that, like, my former boss, the one who dismissed my student complaints out of hand there, was trying to always push to put in our pre-calculus program, and I'm just like, it's not gonna fit. Like, I don't really care what everybody else is doing. We just don't have room for it. So, I mean, I'd like to do conic sections again, but I'd also like to do matrices. Like, right, so the hyperbolic tangent, we want to take the derivative of that. Well, that's going to be hyperbolic sine over the hyperbolic cosine, and then take the derivative. So what is it? Well, that's going to be e to the x minus e to the negative x all over 2 all over e to the x plus e to the negative x all over 2, multiply both top and bottom by 2, so that's gone. And then we're taking the derivative of all that anyway. Right, so then ddx of e to the x minus e to the negative x all over e to the x plus e to the negative x. You can go multiple ways with this. You can decide which way you want to do. You can decide, like, you know, is this something that I want to mess with? Do I want to just trade stuff around? Do I just want to do it in terms of sine and cosine, which usually is the case? But this is going to be the derivative of the top, which ends up getting us just the e to the x plus e to the negative x times the bottom, e to the x plus e to the negative x. Well, that's a little bit easy. That one's the hyperbolic cosine squared. Oh, negative 1. Right, so that's just 1. Right, so derivative of the top times what the bottom is here. Plus the top, which is e to the x minus e to the negative x, times the derivative of the bottom stuff is going to be a negative 1 pulled down times e to the x plus e to the negative x raised to the negative second, and then times the derivative of the inside, which again is now going to be e to the x minus e to the negative x. Maybe a little overkill or whatever, but that's fine. So again, this is just 1. This is going to be a minus. And then here we get a hyperbolic sine squared up top. And on bottom, we get the hyperbolic cosine bit squared. So this is 1 minus, technically this is the 1 minus the hyperbolic tangent squared. But also then we can combine all of it and end up with e to the x plus e to the negative x squared minus e to the x minus e to the negative x squared all over e to the x plus e to the negative x all squared. Right, and then doing these things out, we end up with our middle terms end up dropping out, and then we just get the first terms and last terms multiplied together. So that's not multiplication. Wow. Okay. Well, these are multiplications working out by themselves. So e to the 2x plus, I gotta watch out. This is twice e to the x times e to the negative x is just 2. All right, then plus this squared is going to be e to the negative 2x minus e to the 2x. This is going to be a plus. Again, e to the x, e to the negative x is going to make just 2 overall. And then here, this squared is going to be a plus. But then this distributes in to make a minus e to the negative 2x. All right, all divided by. And this stuff can multiply out. Let's leave it. This all e to the 2x, negative e to the 2x, and e to the negative 2x, and negative e to the negative 2x all subtract out, leaving us with 4. Okay, which is going to be 4 divided by e to the x minus e to the negative x, all squared. This is the same as parentheses 2 over e to the x minus e to the negative x, all squared, which is then going to be 1 over sine. Wait a minute. Yeah, that was plus here. I don't know why I changed it. That's plus. So this is not sine, it's cosine. Hyperbolic cosine. All squared, which then makes the hyperbolic secant squared of x. So ddx of hyperbolic tangent of x is going to be hyperbolic secant squared of x. So, I mean, this is like, again, same sort of thing that you'd see in regular trig. The derivative of the tangent just gets you the secant squared of the same angle. So here, hyperbolics work the same. It's a little bit more work. Of course, I made it longer by trying to prove it instead of just using the sine and cosine identities from the top, but, you know. At any rate. Masahide, you got any questions, comments, random problems you come across? Geometric definition. I don't think so. So I mean, they're like sine and cosine functions in hyperbolic space, but I don't think I necessarily know what their specific definition is. Okay, so I know the catenary. Hmm. Okay. So if we do this with let's use Desmos because I can do this faster. As long as I know which window it's actually in. Alright, so if we do like y squared minus x squared equals 1, that is vertical, so we want the other way. Alright, cosine. X squared minus y squared. So if we want it to be horizontal, it's going to be x squared minus y squared equals 1. And I've never done this, so this may be hazardous to everybody's health. But let's see if this actually works here. Maybe I should have drawn these first. Oh, no. I'll just draw it in really light. Wow. Okay. Really? We'll just skip that one right there. Oops. No, it's up there. I was going to say. Couldn't be that far. Give me 1 second. All right, so if we drew all this in, okay, so we get our x and y. Wait, let me just double check here because I don't want to be completely wrong. Yeah, okay. Foci are there. Y equals. There we go. All right. Absolute value of y equals absolute value of x does give you the full asymptotic space, so that's nice. So what this is, again, this is y squared, no, x squared minus y squared. So taking a random point, x comma y, just happen to be in the first quadrant, because we do that. Okay, so from our basic trig type definitions, we're gonna, wow, draw a totally straight line. Whatever. Boo. Alright, draw in this value. So we want to know stuff about this angle theta. What that means for x and y. That means that here we get right triangle. Theta needs to be between negative pi over 2 and pi over 2. Union with, well, it's either that or it also gets you, no, because that's, we gotta keep it that one angle, right? Because this has to be a function, so it can only have, anyway. Or it can be from pi over, jeez, pi over 4, not pi over 2. Man. Promise I teach for a living. Union with 3 pi over 4, 5 pi over 4. Ah, nope. All round brackets. Okay. Are we not actually looking for theta? Right, we're just looking at the relationship between x and y and not involving theta at all. How do you get the definition then? It's not to there. Right. It's evaluated from the focus. Because the definition of that particular, okay. So the definition of that particular function, right, is defined as the or is it the center? Vertex, whatever. Okay. So really this means that x squared needs to be our hypotenuse, and 1 plus y squared. The 1 and the y need to be our, yep. The 1 and the y need to be our legs. And the x value our x and y value, though, meet at right angles. Ugh. Now you can see me break myself. So... Alright, I'm gonna have to look it up. Oh, pfft. Yeah, okay. Right, because it's from the two different foci. Um, Okay, so if we draw a line, nope, going from one focus, I don't need this to be right here either. Let's move that point to somewhere, you know, pseudo-random here. Okay, so focal length 1, focal length 2, A. Now we're making progress. Right, as this starts going further away, this is not going to be a right angle, right? This is going to be eventually obtuse. So, right, this has to be smaller than 90 significantly. Right now it just happens to look like it, so let's not get confused there. Alright, just in case, let's draw this in again. Somebody's probably going to yell at me. That's fine. Alright, so if this is the relationship, x comma y is this point here, we have our 0 right here. So we have our focus, it's going to be at f comma 0. The other focus is going to be at negative f comma 0. And it's the difference between these two things, these two lengths, is equal to 1. And not the length, the... Alright, so generally speaking, it's going to be horizontal hyperbola. Absolute value of L1 minus L2. 1,000 cranes, hello. Good evening and welcome. So on the basic hyperbola, these foci are actually at 2 and negative 2. But generally speaking, this said that the lengths, these two things, absolute value L1 minus L2 is going to be equal to 2a. In this case, it's just a is 1 because we're not messing with the constants at all. So this should be at 2, 0 and negative 2, 0. L1 here, L2 there. right? Because if we're sitting on one of the foci, then the difference between them should... That's aggravating. All right. 1,000 cranes. If you have any questions, please let me know. I am Obi-Wan Pez. This is N Simplex Pachinko. Your hopefully hopefully your stop for interesting mathematical discussions and fumbling through strange math that I don't know. Um, it's not really all that strange, honestly. This is just it's been um, a very long time since I have done any of this stuff. Um, Masahide, one of my other viewers, suggested that I take a look at defining how the hyperbolic sine and cosine functions are defined, and I'm fumbling through it because I'm refusing to just look it up. Okay, so this is a little weird. So this can't be... These can't be in those locate... It can't just be 2, right? A is 1, but it literally can't be 2 because flattened, that would mean that the foci are on the vertices. It'd be 1, 2 apart. So, yeah. It doesn't necessarily... No, hang on. Oh my god. Oh, is that what it is? Okay, I just had a picture from someplace else that did like the box method, which probably you're familiar with. But basically it said, you know, here's the box which like boxes out the white space in the middle. So that A is going to be this horizontal distance here. B is going to be this vertical distance here. And then C is the distance to the focus from the center to the focus. But that would mean that it is also the diagonal of this box. I mean, not literally because of that, but what I saw was saying that a squared plus b squared equals c squared, which therefore means that that's the diagonal of the box, C, is also the distance out to the focus. All right, let's try it. Let's try and see if we can't find L1 and L2 based on just generic F. So here we get distance x, distance y. Okay. So that means distance x plus f, because that's the absolute value of f, the distance anyway. It's x plus absolute value of negative f because it's in the opposite direction, parentheses squared, plus y squared equals L1. F minus x squared plus y squared equals L2. Alright, so generically we can say, okay, this is just the distance of f. We can just let it be f and not have to worry about pluses and minuses and all that, especially absolute value. It just gets a little weird. So this is going to be, let's just string it, equals x squared plus 2fx plus f squared plus y squared equals L1. Oops, I already did that. L2 is equal to f squared. Let's just back that up. Let's do it the other way. So this is x squared. This is going to be a minus 2fx plus f squared plus y squared. And if we do L1 minus L2, this is L1 minus this, we end up getting a, all this stuff drops out except a 4fx. Right, realistically, again, we can make that the absolute value of L1 minus L2. So it's going to be always the same constant for fx. Allegedly, that should be equal to 2a. A is 1. So that just makes all this 2 is equal to 4fx. I mean, it can't be equal to... It's frustrating. Okay. 1 over 2x, that doesn't make any sense. Alright. Yeah, that doesn't make any sense. Yeah, so 1,000 Cranes, if you have any questions, feel free to interrupt me because, you know, this is a bit of a mess. I'm very willing to talk about just about anything you want to. I will say my like, mathematics above what I teach on a regular basis, which is, generally speaking, differential equations, so like, you know, second year mathematics, is getting a bit rusty, but you know, feel free to throw it on out there and we can kick stuff around like this. I don't know, do you want to enlighten me? how all this is supposed to work. Or we could try something else, but either way. Yeah, this is really awkward because, like, it's supposed to be invariant for x and y. It's supposed to be a constant. So there's something really wrong here. Um, oh, is that really it? No, 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 right. I made these. That's fair. And guiding me blind is not exactly the kind of time you want to spend. Okay. So yeah, allegedly, at this point, um, C is supposed to be both the diagonal of the box and the distance to the focus, which on this particular hyperbola, C is going to be the square root of 2. So, like, that's it, but you should be able to get it from... should be able to get it from other stuff. Oh, idiot. Yep, okay, there we go. Figured it out. This is all squared. That's the problem, right? Because this is L squared, it's not. Okay. Welp. What I always do, just flailing about, seeing if anything falls into place. So it's not that one. This is not L1 minus L2. This is L1 squared minus L2 squared. So forget that. Not sure I like that one too much. All right. Yeah. All right. So I think we're probably just gonna let this one slide. Um, like I said, it's been an awfully long time since I did anything with hyperbolic. I mean, hyperbolic anything, let alone trying to figure out what the actual sine and cosine are defined as. But but no, I didn't want. Jeez. Yeah. Hmm. So that's interesting. It appears to be defined on the area. Hmm. Okay. Hmm. That's wild. Okay. Okay. Let's see. All right, I'm just gonna need to put that over here. Totally. Yeah. almost 3/4 of that circle wasn't complete crap. So I've got what I'm seeing is that we can have a function looks something like this. We get a got a hyperbola that's tangent to it. This is just your standard kind of 1/x stuff. However, in order to make this work nicely, if r equals 1 here, this will all be scaled down a bit. So this technically is going to have to be like, I think y equals 1/√2x. I think is how that's going to have to be. Let's just double check. Nope. Nope, that is not tangent. Okay. Well, crap. Oh, it's just 1/2. Never mind. I wasn't expecting that. Oops. That one. Click. Undo that. 1/2x. Sorry, not half. It's so 1/2x gets yeah, √2/2 as its intersection point. Okay, cool. Anyway, no, that makes complete sense because this is going to be xy equals 1/2. Right, which is going to be the same here. Where if x is equal to y, both of them are √2/2. Or 1/√2. So, okay. So when we do this, this means we're going to get 2 Okay, so we draw just some other function like this, or some other line like this. And within the unit circle, it's going to cause a right angle. Angle theta. Over here, this is going to cause parallel at a right angle. Okay. This ends up being cosine theta. This ends up being sine of theta if indeed the radius is 1. then going out to the hyperbola, this is going to be our hyperbolic sine of theta. This is going to be the hyperbolic cosine of theta. Okay, so if we rotate this to a proper frame of reference, if we just rotate this whole thing 45 degrees, this is going to make sure. Okay, it's going to go like this. This is going to be hyperbolic this way. And whether or not I do angle up or angle down, it doesn't really matter. But let's just do angle up for the sake of argument. Right, this ends up being cosine theta as long as r is 1. This is going to be the sine of theta. And this is going to be the hyperbolic sine of theta. Yeah. Okay. That's the hyperbolic cosine of theta. And the difference between their squares. But they're at right angles to each other, so that's really frustrating. This is where I keep getting hung up here, because we should have that the cosine hyperbolic cosine squared minus hyperbolic sine squared is equal to 1. Which is telling me that the hyperbolic cosine should be a hypotenuse of something. And hyperbolic sine should be a leg of something, of a right triangle. But they're at right angles to each other, so that doesn't really work. I don't know. What do you think? Interestingly enough, right, the hyperbolic tangent appears to be the ratio of the side length, these side lengths, just like the ratio of the original tangent function. That's kind of making me uncomfortable. Because if these are making similar triangles, then the tangent of the original is going to be the same as the tangent of the hyperbolic. It's just going to be the... It's just going to be the same value, like the slope of the terminal side. Which, I mean, maybe that's fine. But at the same time... It's like this thing. Sideways hyperbola. Is this like I did before, x squared minus y squared equals 1? Anyway. Not particularly well, Superbrain. So, Masahide was uh, suggesting that I try to do or take a look at the definition of hyperbolic sine and cosine, because I was noodling around with some other stuff, and I went through a long-winded proof of absolutely nothing, um, and then tried to re-justify how all this was working. um, yeah, no, it's kind of a mess, and not really doing much. I think the main I think the main thrust of it, though, was that the um, area between the angle and the x-axis and the hyperbola is defined as half of the angle itself. So I was trying to, like, you know, prove the formula or something like that. It just, yeah, it's, yeah, I know. It's not pretty. It's probably extremely improper, but either way, if I change it to, you know, alpha or something like that, or just 1, anything, it's not going to come out with the numbers I want here. So this is just me noodling around and not particularly coming up with anything useful. But then again, honestly, what's new? But hey, Happy New Year. Hope everything's going nicely. Thank you. Yeah, there was something else that I wanted to maybe talk about that also bothered me, because I was watching some other video online that was just like somebody doing a random U substitution. Let's just use X. So I saw a particular video online that was like, hey, you know, you don't have to do this whole U substitution thing. I never did it, and it worked out just fine. So, um, his idea here, and I don't want to like call him out by picking on him or anything like that. So I'm just gonna say, like, you know, it sounds like I'm gonna put him down. So I don't want to necessarily do that. But he's saying that for this, you're taking the integral of x times, you know, x squared minus 5 raised to the 1/2 dx. So when you're doing this, you don't have to go through the whole, like, u equals du equals thing, go through all of this and then go to the end. He said from here, basically, you're saying that this is going to just be like x squared minus 5 raised to the 3/2 times 2/3 and then say, what did I need to do to get to this place? Because if we take the derivative here, what's that going to get us back up here? And so he said, oh, well, here, you need a 2x as part of your derivative. You only have an x, so therefore it's going to be a 1/2 here. You're going to multiply these things. And then, like, this is it. You just take the next step to solve what this is going to be, or, simplify whatever this is going to be. So in this case, 1/3 x squared minus 5 raised to the 3 halves plus c. And I get his point. Is that really he's like saying that, you shouldn't get fixated so much on trying to find all of this. And I was like, well, first of all, this right here is missing kind of a lot of intuition, or it's just like requiring a student to have that intuition, and a lot of those students do not have the intuition to go just from that step to that step. And he's like, no, I don't mean to do this in like the beginning of Calc 2 or at the end of Calc, whatever, end of Calc 1, beginning of Calc 2. I'm meaning like, as you're going through in Calc 3 in differential equations and all this other stuff. I was like, okay, so first of all, my students, when they do this, will say this is going to be x squared minus 5, which is to be expected. This is going to be 2x dx, but then he went on, and this is why I'm not calling him out, he went on to say that here dx is going to be equal to, and he used one that was only a constant, so I will give that to him in his credit. To his credit, he did this where it was just a constant, so it was just over 2. But my students do this. So my students often will do this, and they'll say, okay, well, dx is going to be equal to du over 2x. So then here, this becomes the integral of x times u to the 1/2 du over 2x, and now our x's will divide out here. And then this becomes the integral of u to the 1/2 du. Now, I am saying that this step is an awful atrocity and you should never do it. Because my students will also... yes, because my students will also say exactly, it's really lucky, that when you have the square root of x squared minus 5 dx, that we should be able to do the same thing. So therefore, u equals x squared minus 5, just like before. Du is equal to 2x dx, and therefore dx is equal to du over 2x. So then they take this and say, okay, this is going to be the integral of here, again, u to the 1/2 times du over 2x. And I'm like, okay, now what? And the ones who don't know what they're doing get stuck here. They're just like, nope, I don't get it. The ones who do know what they're doing, well, they never go here in the first place because I tell them not to. But this is a required trig substitution. You can't get anywhere without it. I mean, not really. E raised to the negative x squared. Okay, so yeah, so they pretty much do the same thing, right? It's u is equal to negative x squared, therefore du is equal to negative 2x dx, and therefore dx is equal to du over negative 2x. I just doxed myself. Great. All right, that's coming out of the clip. What does it matter anyway? So anyway. So what does it matter, Mr. Obi? That's coming out of the VOD. Timestamp 2:16. Cool. Well, I mean that's not my last name in terms of this. It's Pez, right? Because Kenobi would be a total Oi. Yeah, Kenobi would be a copyright violation. Although Pez is a completely different copyright violation. Oh, I'm in the American like pseudo South. So this is a place where they say like, you know, Mr. first name or Mrs. last name or Ms. last name or Ms. first name. Sorry, first name. It's always Mr. or Ms. first name. And it's kind of a weird thing cuz like my spouse and I grew up in the Northeast. So like that's not a thing where we're from. But anyway, so the yeah, so my spouse and I like we came down here and everybody's calling us like, you know, Mr. Obi and Ms. Spouse. And we're like, what? Like I don't understand. Why are you calling us that? And they're like, "Oh, it's like a southern thing." We're like, "But you keep saying we're not in the South." So actually, it's not Miss. It's Ms. So like, you know, so Mr. John Doe equals Mr. John. And so like Ms. is actually not Miss. It's slightly different in that it is a like it is a title that you give to any woman regardless of marital status, whereas Miss is someone who generally speaking is unmarried and Mrs. is someone who is married. At least in English, because you know English is weird. So your title depends on your marital status is essentially what it is. Unlike for instance, right, in France, generally speaking, you say like Madame is any woman and Mademoiselle is any girl. So like French women who are in their I don't know 20s, 30s, something like that, take great offense to being called Miss because it's like you're a little girl to them. So my French teacher went to France and was very embarrassed when the shopkeeper was like, "Pardon." Je suis une madame. And the lady's like, my French teacher was like, "Oh, terribly sorry." Like, okay, take my foot out of my mouth on that one. Um, Yeah, it's a really weird thing. Um, so actually, where does the line get drawn with Frau and Fraulein? Is that sort of the same thing where it's like age-ish, age dependent? So like you never say it to anyone who isn't actually a small child, or like culturally speaking. Oh, okay, I see. So like nobody ever uses it, pretty much. Interesting. So getting back to this thing. Oh, oh, so it's like it's demeaning. I mean, not super demeaning, but like it would possibly feel demeaning to. So does the same thing happen for? Yeah, does the same thing happen for boy children? Is there some other word that they use other than their full name or um oh. Why am I am totally blanking on the proper on the pronoun for Mister in German. That is terrible. I mean, I only took one semester, but at the same time, like I knew Frau and Fraulein off the top of my head, so it's here. Yeah, jeez. Oh man, it's only been 20 years. Come on. Yeah. So anyway, like this does not work. My students are like, what's the problem, Mr. Obi? Um, what's the issue with this? And the problem is that of course you don't have an x to spare in the first place. You're not dividing out anything, and you're also mixing variables. So it's like, what are you thinking? What are you doing? Interesting. So with something like this, one of the things that I had suggested in this particular YouTube video was like, so hey, I know that this is like okay to do in this particular case because it actually does divide out, but I don't think we should be encouraging this. One, because it's sloppy. Two, because you're mixing variables. And mixing variables is like the big thing that you are not supposed to do in differential equations, especially if you're looking at something like, you know, xy prime plus, I don't even know, plus y equals um, 3x squared. So, like, you find a linear. That's probably a bad idea because that's not separation of variables. But plus x squared is equal to. Yeah, this is just going to screw me over. Why am I doing this? Sure, why not? Is just equal. Let's just equal to 0. So when you get something like this in differential equations, you're looking at this and saying, I need to separate the variables. I don't like where they are in this. So we can multiply by y, divide by x all the way across, and move this term over to the other side at the same time, or do it in a series of steps, however you feel like it. So when you get this, now we can separate the variables, multiply by y on both sides, and divide by x on both sides. So then here this goes away. This is y prime. This is going to be equal to negative x. And then also this here, we can split the differentials to make y times dy dx equals negative x multiplied by dx. So y dy is equal to negative x dx. So now this becomes a much nicer, at least in some respects, much nicer differential equation to solve, because now all of your y's are on one side, all your x's are on the other. You got your dy's, your dx's with the appropriate variables, and it's all separated. So I encourage my students to do the same for this, is that look at this and say, okay, this is going to be like a big... So if we divide the initial equation... I see. So the issue with stuff like that is that you still got your... Alright, hang on. Let's look at it. Alright, x. Eh. Alright, so dy dx. See, oh, just this. Right, yeah. Okay. So yes, but now you've got something with um, implicit differentiation, which you in theory you can do it, but at the same time you got to remember that y is now a function of x also, or at least that's generally speaking how it's written. So so like what function when you what function when you take its derivative is going to get you negative x over y? Right, because this is the quotient rule. After the quotient rule has been simplified. So like... so like this would be... yeah, yeah, that's the problem. Is that like, okay, you'd have to do um, f of x is equal to something such that and g of x is going to be something such that f prime g is equal to, or f prime g minus fg prime is equal to negative x, and g squared is equal to y, but it's not necessarily going to be that, so it could be like this is y squared and this is minus xy, right? But this is all going to be just all messed up. It's possible like one of these terms canceled out. They were like each one or two terms and just dump stuff, and who knows. But yeah, I'm not going to do this in my head. So I'm going to use separation of variables on this. So I go down here and I say, okay, if I put all of my y's over there, all my x's over there, this becomes almost trivial, right? So now we can take the integral on both sides and we get a 1/2 y squared on the left and a negative 1/2 x squared plus c on the right, plus c is arbitrary where it goes, your choice. Multiply by 2 on both sides. This is y squared is equal to negative x squared plus a different c. So it's a circle. Yeah, like this gets pretty nasty. The other thing that you could have done here was said like, wait, dy dx is equal to negative x over y. This is an awful lot like the negative reciprocal of the right tangent of theta is equal to y over x. And then this is like negative cotangent theta, which is equal to our slope. So like there's some relationship that you could create here and then be like, oh, well, hang on, that looks like a, that looks like a circle. I don't know. It's possible. I wouldn't have come up with it like that. But with all of my years of doing trigonometry, yeah, definitely. So my point here was, why don't we just do separation of variables and like do this as a foundational skill to say, if you can separate variables here for this in Calc 2, then it becomes much easier to do separation of variables in the actual differential equations class. Of course, my students also do like differential equations 1 in Calc 2 as well, where you get basically it's you can do separation of variables and here's the classification of like what differential equations are. So this is a linear first order. No, it isn't. It's nonlinear. Right, because this is a yy prime. Oops. But anyway, yeah, first order nonlinear homogeneous, non-homogeneous, right? Because it's got a negative x, non-homogeneous differential equation. Right, which is another thing that I need to curb. Is that, look, you want to do a substitution? Well, you're just introducing another variable. That's just like, creating this other layer, just like a differential equation. You've got to respect the same rules essentially. My number one rule is you only take, or you never mix variables in the same integral. So That's just one thing that I always make sure that they listen to, is you just always separate your variables, get them into different pieces, because otherwise it really messes things up. I mean, the really awful one is when you do something like, you know, take an integral like the one we had up there, x root x squared minus 5 dx, and you're taking this from like 3 to 8, right? And then the students do this, and they say, okay, I'm going to go from, um, you know, again, u is equal to, even if they do it right, you know where I'm going with this. Right? Even if they do it the way that I think about this, they go like this. You know, 1/2 outside with a 2 inside, x root x squared minus 5 dx. Okay, 2x dx is now equal to du, so we replace it. 3 to 5, 1/2. This is the integral of u to the 1/2 power du, right? Yeah, this is something that always happens. Somebody does it, and I'm like, you always, if you're gonna like try to mix variables, you definitely want to write that down, right? This is still okay. You have to define which variable you're doing it on, because if you just wrote this, that's wrong. Because 3 to 5 is on u. Yeah. So you'd have to say, okay, this is x equals 3 to 5. That's okay. I will allow that, because you can solve this, go back, and then say, okay, when, you know, u was raised to the solutions, you know, 3/2, this is, again, 1/3. 1/3 u to the 3/2, where x is equal to 3 to 5. Now they can come out of this and say it's 1/3 parentheses x squared minus 5 to the 3/2 from x equals 3 to 5. And whether or not they put x equals here, I don't care, because it's the only variable. So, like, this is valid. But at the same time, they could also say, well, what's u when x is 3 and what's u when x is 8? So they could just do that here. Okay, so then this is going to be 3 squared minus 5 is going to be 4, and 8 squared is 64 minus 5 is going to be 59. So, like, why not just do that, right? Integral 1/2 from 4 to 59 of u to the 1/2, which I know, like you said, students might be a little bit more hesitant. Right? 64 minus 5? Did I mess it up? Oh, yeah, yeah, I messed that up. So it should have been 8 all the way through. There's the problem. It would have been less work to just change the 1. Yeah, I started doing this 5, I think, and just copied it everywhere. Yeah. No, not today. Oh no, what was it? It wasn't this one. No, what was the... it's a meme. Anyway. I don't need to mess with that. Anyway, no, not in this case, because I was careful. If I did x goes from 0, then that's an issue. But as long as x is larger than the square root of 5, we're good. Right, because this is that. Ew. I can do better. It's that. And technically, I guess it also would put something out here, but again, we don't care because it's outside of that domain. So again, this is at root 5, 0. So then 3 starts here. I mean, useful in its own right, but not today. I mean, like, I could go and get my complex analysis book, but there's so much stuff in there that I completely forget how to do. Oh no, that's what it was. Yeah, the meme was the limit as x approaches 8 of 1 over x minus 8 is infinity. They were doing from the positive side. And then the teacher was like, all right, so what's the limit as x approaches 5 from the positive side of 1 over x minus 5? And the kid wrote that. Makes perfect sense. I don't know what you're talking about. You mean I'm wrong? What are you marking me wrong for? This was clearly in your example. Yeah, so the purpose with complex analysis, and I'll very brief. Purpose behind complex analysis is like you take some crazy function that don't even need that much space, but take some crazy function that's like this, and it's really nasty in real space. You can actually translate this into, instead of x, y, you can translate it into z, which is real by imaginary. And like, you know, this section here, yeah. Oh, you probably remember this then. Or at least what it looked like. You just take some function like this, and you're like, well, basically, this can, if we recenter it and do all this other stuff, it doesn't even have to have a pole in this particular case. This is just equal to a semicircle under some transformation. really miss the days of actually being able to just jump out there and be like, ah, here's a thing. Let's find the actual value we can get and just get a value of an integral that is totally impossible to solve, right? I mean, like the one you gave, right? The e to the negative x squared. I guess that one doesn't necessarily. Does that require complex analysis? I forget. Yeah. So then like area equals pi r squared, and then you just translate it back. And you get like 5. Like I said, I kind of miss those days where you can just throw something into a complex integral, get a simple geometric solution, and then translate it back, transform it back to real numbers. Just have a number. Complex analysis applications in real life. Signal processing, Fourier analysis. Uh, Electrostatics. Oh, yeah. Yeah, one of my classmates back in we were in a Calc 1 seminar. So it was a studio. It was a studio class that combined calculus and physics. And so it was a full year-long program, and I ended up getting a 4 on the um, Calc AB AP exam. So I didn't actually have to take this, but I was so nervous about it, and I was like, I really think that I should do this. Like, it's a pretty cool program. I think all of the physics majors, like save one or two, were also in this, and so I was like, no, out of 5. If I'm honest, I have no idea how I did it. I went I went through the exam and I'm just like, oh, I'm like, I don't know how to do this. I just wrote down whatever I could remember and then came back to it a bit. It was a bit like the SAT where you have to do like, this section is a certain amount of time and then this section is a certain amount of time. So like once you're done with this section, you can't come back to it. There was like multiple choice stuff, which I must have gotten pretty close to 100 on. And then there was like, big questions at the end, which I must have done okay, I guess. Um, but yeah, it was pretty tough. Um, I remember thinking that I just failed outright, and they came back and they're like, "So we're gonna give you, uh, or the my university was like, So we'll give you credit for Calc 1 and Calc 2. So that was like the full year course. And then you could just jump right into whatever else you need to take. And then also they were like, oh, and by the way, you could just take, um, or we're inviting you to this studio course, which is going to be a combination of calculus and physics. It's going to show how they are all interrelated and all this stuff. And I was like, yeah, I want to do that. And I feel like my calc skills are not completely up to par, so yeah, I'm going to do that and not like jump ahead to Calc 3 and it would have been Calc 3 differential equations and linear algebra, which I mean, as separate classes, it turned out not to be that hard, but I also like they took that class and then they were like, everybody in here, we're also inviting you to next year doing a full year of all three of those classes. So the Calc 3, linear algebra, differential equations, all as one gigantic class. And we'll like intersperse all of the information and show how it's all interrelated. And I was like, that's really cool. Let's do it. And first semester I got a B. Second semester I ended up getting mono at the same time. So I was just like, I scraped by with a D. And they were like, yeah, that's not going to work. Hooray. So like you can either retake the entire class or you can wait for the second half to come around and just take the second half of the course, which is what I did. Um, did okay. Or you could retake all three classes separately, and I'm like, no, that's not an option. I passed the first semester of this, and you can't give me partial credit for anything, so yeah. So it was a little rough. It was also the semester I had mono was also the semester where I was doing my student observation as a teacher in a public school. So I'm sitting in the back of class like mm. These high school students are like, what's up with that guy? Finally, with about 2 weeks left, yeah. Finally, with about 2 weeks, my problem was that I didn't really get it. Like I wasn't invited to do anything until pretty close to spring break. And then they were like, here, you can take my teaching notes and study them at home and then do, like, you know, teach a class. And like I said, I had about 3 weeks, maybe, where I was teaching. And, you know, it's still only once a week. And basically, I took the teacher's notes and was just like, here's a bunch of problems we can do on the board, and it was just example after example after example, and I was just like, this is terrible for both me and them. So this is how I like started developing the ideas, very very rudimentary, of course, of like what I do, where I'm like, I can't just throw out problem after problem after problem and give them a formula that they're going to plug stuff into. I need to teach. I need to like show them how it exists, why these relationships exist. And then somebody recently, what was it? I was watching a math video yesterday. I mean, of course, but um, where somebody said like, you know, mathematics is not about showing absolute truth or absolute relationships, or the mathematics is not about absolute truth. And I was like, wait. So mathematics, well, not quite. So mathematics is about finding a set of axioms which are assumed to be true under certain conditions. Yes. And then from there, this is where we come up with basically three groups. Things that, yeah, relative to the axioms, and it's not just like facts, right? This is relationships that must be true given the axioms, relationships that may be true under other conditions, and relationships that cannot be true. And so I was like, think that I need to, I think that I might need to, like, kind of like soft reboot my uh, pre-calculus class, and instead of framing everything in terms of like the history of math, because I love it, but at the same time, like I don't really get that far with it, and it's taking a long time. I might need to sort of soft reboot it and frame this on day one, or even put it into uh, the history of math as the context for this. And be like, okay, you know, people are coming up with relationships that exist. You know, clearly 1 plus 1 equals 2 as long as you can define what 1 and addition are, um, and what 2 means. Uh, but yeah, it's going to be an interesting philosophical argument. So see where that goes. Yeah, I was my daughter's in fourth grade math now, and like she was asking about um, we were just doing like multiplication facts, and like, you know, let's do some practice because she's she's good, but she doesn't have like the intuition to just, or she maybe just has the intuition but hasn't memorized the solutions to the simple stuff. So it's like she has to think about it every time. You know, what's 4 times 7? Okay, what's 4 times 5? Now go from there. Right. So like I said, she's got some of that intuition, but just not. It's not quite there for her. And so we're trying to work stuff out. And like at some point, I did like what's 18 times 6 or something like that, and she was just like, what? I'm like, all right, well, you know, it's kind of up to you how you want to do this, and you can, you know, there's so many different ways to choose from to multiply this out in your head. Like, I don't like this as it is. I'll say that, yeah, 8 and 7 for me. It's the same sort of thing. It's the sevens. I think it's just messing with our heads. Um, so I mean, the way that she's like supposed to learn it is that this is 10 plus 8 times 6. And so I'm like, okay, so what do you do with this? And she's it's slowly getting there, but it's, oh, right, this is going to be 10 times 6 and 8 times 6. Well, guess what, guys? That's distribution. So I was telling her at some point that this is actually something that I can do in my head when you try to do a much bigger type of, 23 times 87, I think was something about what I said here. See, I didn't have Minecraft when I was doing this. So, like, here, this is going to be a nice, simple 60 and 48, which makes 108. And so I got her to figure this out step by step, but we got there eventually. And then I said, this is the same thing I do for bigger stuff like this. If I want to figure this out in my head, I'm doing the same thing. I'm going to say that this is going to be, 20 times 87 and 3 times 87. And then, guess what? We do this the other way too. So 20 times 80, 20 times 7, 3 times 80. Oh, 3 times 7. So close. And I actually explained to her, you can generalize this so it works for anything. And she was like, "What do you mean?" And I'm like, "Okay, you're only in 4th grade, but let's just assume that you want to do, 10 plus 8 is the same as any two numbers a plus b, and then you want to multiply by c, which is some other number." Well, yeah. But I mean, I also said you can make this work for any numbers that you want. And I said, okay, so if you do this, you say that, this is going to be just like you did over here. 10 times 6 is a times c. 8 times 6 is b times c. And then a is 10, b is 8, and c is 6. And she was like, okay. So then I said, okay, you could do the same thing here. You just make c a more complicated thing. So this is going to be a plus b times c plus d. And then, you just end up multiplying this out. So a times c plus d plus b times c plus d. So I think she's getting the power of it, even if she can't quite understand it. It's like, oh, this is a thing that you can do. And I don't see it yet, but... And that's really the foundation of it, is like, basically destabilizing a student, not... not in that sense, maybe, but destabilizing a student's comfort to say, like, here's a thing, and then they'll be like, how does that work? And that's where you hook them. To say, I can show you how that works. Let's see the relationship. Yeah. Well, I mean, especially at that age, like, she clearly hasn't done anything with algebra yet, really, apart from, they do some stuff with, like, the boxes. So, like, 3 plus box equals 7. So you're guessing to fill in the number, but then at some point the teacher's like, what would happen if you subtract 3 from this side and 3 from this side? It's like a scale. I don't know if the elementary teachers do this, but this would really help. Is that, like, if you show them a pan balance and say, like, okay, if we take 3 off from this side, it's just going to go clunk like that. So if we have to take an equal amount off of both sides, then we end up, like, keeping it equal. So then over here, we don't have this anymore, we just have the box. And then over here, this is 7 minus 3. Well, that's something you can do, so that's a 4. Yeah, I mean, we didn't do it until algebra. So that's like 8th grade. We did some of like this basic stuff at 6th. Maybe 7th and 8th we did like literally this. Where... Or 7th grade. I guess in 7th grade we might have done something that was literally this. Where we're actually taking like stuff away from both sides to remove it. Well, yeah, so I'm sure our schools were very different, not just culturally, but like um, also in terms of like, I mean, American schools in 6th grade when I was there, right? And this is a difference in time as well as in actual physical space. My 6th grade New Hampshire elementary school um, taught a lot of like fractions, decimals, estimation, and the 4 basic operations using those things. Now, granted, a lot of it ended up using stuff like I would say probably this first line. Mm-hmm. Our schools generally from state to state are pretty similar in terms of like what is taught when, with few exceptions. Um, and especially now that Common Core is in, they're pretty standardized across the board. My 7th grade was weird because I was invited to a program. This is a common theme, by the way. I was invited to a program called Integrated. And so the integrated classes took a bunch of our middle school classes and moved them physically to the high school. It was still middle school. We were still taking middle school 7th grade classes, so it wasn't like they were, super advanced or anything. It was just literally, we didn't have any room in the middle school, so we shipped a whole bunch of our students off to the high school, which was about 200 yards down the street. So every morning, our honors. So we had one group from each of the levels. So we had a 100 level, which was honors, 200 level, which was like college prep, 300 level, which is basically like you're just trying to get by, and 400 level, which was like you need serious, like you're. The 400 level was basically like you're going to maybe graduate high school. And of course, students could take any level for any particular class, but maybe somebody was at a most likely a 2, or if they're in a 400 for anything, they're almost certainly not going to be in a 200 for anything in particular. But there could have been somebody who was like really good at English but terrible at math, or vice versa, or something. Anyway. So our integrated class took a bunch of students who were all signed up for the same numbering level. So all 100, all 200, all 300, all 400. And then they just shipped all of us off to the high school. It was like one class of each. And then we had all 4 of our classes in the morning session. So, I did, we have homeroom where we all get our attendance taken. And then we went to our separate classes, which ended up for me being like, I don't know, science, English, math, social studies, you know, those four in some order, and then all four of the groups just basically rotated around until they got everybody. And then we'd go back to the middle school for lunch. And then the afternoon session was like our other stuff. So for me, it was band, French. Don't even remember. Like music class, French class. Oh, gym, right? And art, I guess. Although those were on different days, so whatever. Um, I can't remember. We might have also done. Yeah. Anyway, irrelevant to the story. So, but yeah, our class was this integrated program, which took again one class of each grade level in seventh grade, and then shoved us all into the high school. And we all had the same. It was supposed to be like sort of a bonding experience because we have all the same teachers. We're always with the same group, and that cohort pretty much is always going to be together. So there was one, um, like our honors group was in all four of our major classes together, and then of course we're half of us are in like the same music and art and whatever classes. So like of course we're going to bond over that stuff too. And it was kind of interesting. We did all sorts of crazy stuff. Um, but like the integrated class by itself went off to go do something. Pedagogically, it was kind of interesting. But our seventh grade math was like this weird hodgepodge of all sorts of stuff. And so we did like mechanical advantage and data analysis, and it wasn't like we weren't really doing pre-algebra skills. It was like a lot of weird. So like our class, like the whole school, all of seventh grade is a cohort. But then also within that, our everybody, I shouldn't say everybody, um, like the 25 students who were all taking um, seventh grade honors, like all honors, and were asked into this program, and I have no idea how they selected, but all 25 of us were like a cohort, like a small cohort, out of the much larger one. So my eighth grade experience was much different. In eighth grade, we had two classes that were a combination. It was English and social studies. And so, like, what we were reading in English reflected the time period that we were trying to study in social studies. So we had this, like, progression through American literature, essentially. um, in eighth grade, though, everybody just kind of signed up for whatever classes. We had an IG integrated 8, but I was not a part of that because I was part of this other um, English social studies combo. So IG8 also had like the small cohorts 1, 2, 3, 4 that were over at the high school, and again they did cool stuff. Let's see. No, my eighth grade year was also the year that Apollo 13 came out, the movie, and we ended up like the local theater rented the reels, and so as a class, we ended up taking like that block that we were supposed to be in English and then social studies, and that block we ended up going to the theater and watching a movie and then having a discussion. But nonetheless, it was like we want to The teachers were probably like, well, we want to watch Apollo 13, so let's get the kids to do it. And they all got paid for it, so hey. Um, but anyway, so the rest of our classes were kind of scattershot. Um, so I was in math class with a lot of the same people who were in the English social studies combo, but there were multiple math classes in eighth grade. Well, hang on. So there was like eighth grade math, which is pre algebra, which still had an honors level. So like you had to be really good to be in it. But I got invited to do algebra 1. Hey, only I can do that. um, so yeah, I got invited to algebra 1, and so I I only had like 20 students who could possibly be in like a bunch of my other classes, and most of them weren't. They Some of them, well, probably most of them were in the English social studies combo, but I believe that there was a second one that had the same people, but it was reversed. It's like the time periods were reversed. So like half of us were in that one and half of us were in the other one, and our science classes um, were all the same at the honors level. So like there were 4 different ones with different teachers. So only about like half or a third of one of these classes was in that science class, timing wise, you know. So our core classes, the English, Math, Social Studies, English, it was kind of a grab bag. I ended up stopping at one point, and I looked at this girl, and I went, "You and I are in every single class together." And she was like, "We are. Oh my god." Because we were in the same 4 core classes, which in eighth grade, again, mind you, was not common. We were in the same French class. We were in the same gym slash whatever else, and we did band together. I think that was the only time that I've ever had somebody in every single one of my classes across the board. Like ever. Obviously after elementary school, because elementary school we're always all together. But 7th through 12th grade, I don't think it ever happened, except that one girl that one semester. All right. I think it's probably about time to start looking. Ooh. Okay. So JCM's on. No, no. She was very nice, and I kind of liked her, but no, she was she was not my spouse. Um, we never dated. That and oh, and she and like 5 other of like really close friends slash people who were in a lot of my classes. It was probably more than 5, but all went to the private high school um, up the street, and so like they were gone from my life. I'm just like, oh. No, my spouse and I met at college. I was dating somebody else, and uh, she was a year under. She was a year below me. So like, I'm a freshman. She's now a senior in high school, and the long distance thing was it was okay. It was working out, but like, I'm I'm I don't do well on the phone, especially when I got a lot of other stuff to do and I'm busy. So, you know, relationship was strained there. We made it to our sophomore year, and she was like, "I can't do this." And she was my sophomore year, her freshman year at Boston University. I was at University of New Hampshire, so it just wasn't happening. Um, and again, I like took the train down to see her, or she took the train up to see me, because there was a nice train that started running about the same time between the two universities. So it was really convenient. I mean, it's not because of the universities. There's a lot of stuff in between and a lot of stuff beyond the university. But like it stopped in Boston and it stopped in Durham, New Hampshire at the University of New Hampshire and then kept going up to upstate in Maine. So anyway, she and I went our separate ways. She was originally going to be a law student, and like years later, I find out that she is a math teacher at the University of New Hampshire as a grad student, and I'm like, what the? When did that happen? And she went on to be like a public school teacher, and I was like, uh, it's crazy. Like she seemed to not have very much interest in specifically teaching math. Like I don't know, I just don't know where it came from. The life changes, I guess, and just happened. I was like that's amazing. So actually, if I had stuck around in grad school, I would have been finishing my master's when she came in to start hers. That would have been like high. But yeah, yeah, and that was her grad school experience, and I was already gone by that point, so whatever. But yeah. So anyway, my I was working as an RA, resident assistant, in my dorm sophomore year, and sophomore year, like you're still a little young, right? I just turned 20, basically, or like a little ways through the year. I'm turning 20, so I'm still really young compared to a lot of other people who are there. And like, I have authority. Uh-huh. Yeah, sure. So all the upper class people are like, okay. I don't mean that in terms of, socioeconomic. Like all the people who are in the upper 2 years are like, yeah, okay. Who's this kid trying to tell us what to do? But whatever. So the RAs, there were three of us, get together with the hall director, and we had a week where we just like hung out, did team building stuff, get the plan together as far as what we're going to do for the year, right? Everything went great. We loved it. All of each other were great. It's that honeymoon period. Um, everything's great. Um, and then let's see. After the first week, we had about like a half a week to a week where the hall council came in. So um, each year the hall elected a president, vice president, treasurer, and secretary to like run the hall, and like how does our money get spent in just our hall. That's it. So we have hall dues. Everybody pays in like, I don't know, $50 a year or something like that, and you get to take advantage of all the stuff that we do over the whole year for free. So, or it's prepaid, really, is what it is. And if we have a lot of money, then we can do a lot of cool things. And then every year there's always like, a couple $100 at the end of the year that's kicked over to the next year. So we're doing this initial thing where we meet the hall council after our first week of just the hall directors and the RAs together, and we start talking, and you know doing icebreakers and one-on-one conversations, and I talk with the president, the vice president, the secretary, and then I get to the treasurer, and we're talking and like, oh yeah, I really like, I'm really into math, and she's like, I'm kind of into math. That's interesting, and she's like, well, I'm also double majoring in theater, and I said, oh, I love theater. I can sing like, all of Les Mis, and she's like, you sing? And I'm like, yeah, I do bass, and she was like, okay, interesting, and internally, apparently, she was like, he likes Les Mis, because that's one of her favorite plays, and yeah, I'm a bass, or I have have been a bass with our local choir. Obviously, the last couple of years have been not great for public singing, spraying stuff out of your mouth. Um, but yeah, I used to used to regularly sing in a choir, and we did a lot of there's this thing. No, um, yeah, we did a lot of like it's kind of weird. So we belong to a Unitarian Universalist group, so a lot of different culture goes into the music that we pick. And the guy who ran our music thing was like a professor at a very seriously world-renowned, music conservancy. And it's like, okay, I guess he's got some clout and he knows what he's doing. Oh yeah, there was like, at some point we were explaining to somebody like who are we were explaining to somebody like who we sing with or who we sing for, because oh yeah, our director is this guy, and they're like, oh, you know him? I'm like, yeah. It's like within musical circles he's like amazing. Like, okay. And then our pianist, who became our organist when we bought an organ for the for the church, um, and also is now our music director since the other guy retired, was once his student at that conservancy, and so it's like, oh. Anyway, so yeah, we're singing all sorts of stuff. At some point, yeah, she was like, "Oh, this guy," and then in my next line, in my next question, there was something, and I was like, "Yeah, my girlfriend and I," and she was like, silently, like, "Damn it." So after after the first semester, girlfriend and I broke up, and um, it was move out day after our finals. And like, so I'm checking everybody out and saying like, okay, your room's clean, your room's clear of whatever. And then it wasn't a problem if people were just going to live there, right? If they're going to come back to the same room, then it doesn't matter. But this particular group, like, there's a bunch of trading. They, move across campus. This group of people over here splits into like two different rooms. There's all sorts of moves. And so I'm checking out I checked out the ladies who were in this particular room, and then I checked in probably like 6 hours later after I got that phone call from my girlfriend when she was like, okay, we can't do this anymore. I'm checking in three of the members of the hall council into this particular room because, they work together, so why not also live together? And they've been living together since freshman year, so Like all they do is hang out together. So of course they want a triple instead of like a weird double downstairs, like two different doubles or whatever. So yeah, they move in, and I'm like in the middle of my first round of getting hit with denial and depression of I have just been dumped. So I'm like going down the checklist, tears streaming down my face. It's like, ugh. They're like, "You all right?" I'm like, "I'm fine." So yeah, like we come back, and I'm 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 still not feeling great, but at the same time, I'm like, "All right, you know what? Let's do this. Let's be single for a while. It's gonna be fine. I don't I don't need like I don't need a relationship to be happy, right? I'm fine right now. Let's just do this. Let's get through the semester, and I can figure it out some other time." So, um, sometime around like Valentine's Day rolls around, and I ask this other girl out who's been, making eyes, and we date for like 2 weeks, and it was fun, but it just, yeah, not gonna happen. Not the kind of relationship that either of us wanted. And so a few, it's like a couple of months, or like a month goes by, and the two of us are part of a larger group that does medieval stuff. So like we founded the Medieval and Renaissance Club at our college, and so this was a supposed to be an offshoot of the SCA, or Society for Creative Anachronism, where like you create a persona and you study the history behind that person's um, culture and history and things like that, specifically pertaining to the Renaissance period. And then you can do all sorts of stuff. So our particular interests ended up being like beating the crap out of each other with rattan sticks, and making making chainmail armor, because that's gonna be cool. Um, I gave myself a nasty case of carpal tunnel syndrome because you twist like this all the time to get the rings in place, and you loop them through and pull and loop it through and pull. So it's this repetitive strain injury. It was just awful. Um, but yeah, so the Society for Creative Anachronism has a like fighting club where you physically make armor or borrow it from somebody else, and then you get trained in how to fight in medieval style with swords, with, well, sword and shield is first. After you learn how to do sword and shield, and you get accredited basically, then you can go do other weapons. So you can go do whatever you want after that. So some people did like, long, um, some people did two-handed like bastard swords. Other people did pole arms. So that was where I wanted to go. I wanted to do glaive. So you have a 8 foot pole that has a like 2 to 3 foot section at the end that's taped off, and if you hit anybody with like that section, that's considered a hit. But then the guy also had a I mean, it's basically LARPing, but at the same time it's a lot less structured. It's basically like, hey, let's pretend that we're extras in Braveheart. Go. But yeah, the one guy that I was looking at had a he was his persona was a Spanish, well, he was a Spaniard anyway. So he had like the Don Quixote, like the round helmet with the brim that goes all the way around. He got a brand new one, and then brought it to the fighting club like the week that he got it. So he puts it on his head and he gets it strapped in, and it's got a face shield, so like you can't get you. One of the rules is like you have to have a basket around your face because we're not going to play that game. Um, and then you have uh, camp foam padding, like the stuff you lay on when you go camping, all on the inside of the helmet, so that if you get whacked in the head, it's not going to actually hurt. So he's got a glaive, and at the one end he's got 3 feet of like sword, which is basically just, I mean, it's a glaive. You know what a glaive looks like probably, but 3 feet that's got tape on it on one side, so that's your blade. And then it's a piece of rattan, which is very similar to bamboo. And so the other end, he had a spike, but it wasn't a spike. It was just a big piece of foam with duct tape all over it. And so, like, he'd smack people like this to try to get him back, and they're blocking with their shield. And somebody comes in to try to attack him with a sword, and he takes the long section, and he's not able to hit him anymore because they're just too close. So what does he do? He whips it around this way and takes like a 2 foot section with the spike on the end and just biffs him right underneath the chin, gets the guy, gets a point. It's not like a problem. It's just like, oh, okay, didn't see that coming. So the guy redoubles his effort, sees it coming this time, blocks it down, and takes his sword right off the guy's helmet, which makes a sound that every single person dropped what they're doing and turned around and went, hey, because it just sounded like a bell all the way across the whole parking lot. Just anyway, you see where my ramblings go. I should probably change to just chatting, but whatever. Yeah, fortunately not, but man, I mean, it must have been pretty loud. You're about that far away. um, so anyway, yeah, we're having fun with this, and we decide that we're gonna go to a brewery meeting at one of these guys' houses. Now, none of us are 21, mind you, so we can't drink anything. But and yes, that's the age in the United States because apparently religious. Um, Tangent. Realistically, right? This is just a story version of this. So anyway, we decide that we're going to go to a brewery meeting and like learn how to brew stuff. Now, no, we can't drink it, but we can at least learn because it's interesting. And there's not going to be another one for who knows, a year, two, five. So of course we're going to learn. So they start talking and they're like, okay, so one of the things that you want to learn how to do is learn how to make mead because mead is like, one of the principal drinks for the SCA. So basically, you get honey, you get some water, and you get some yeast, and that's it. We're like, oh, huh. So, there's a lot more art to it. And then, like, when do you do things and stuff like that. But, we took notes and, oh, so that's all you really need to start it. That's good to know. Thank you. Like different kinds of yeast. You want to use a champagne yeast or a beer yeast or whatever. Yeah, so I have actually since made tepache, which is um, um, I mean, it's essentially mead, but it's made out of pineapple, And basically, I just took a bunch of pineapple and water and sugar and shook it up and put it in the fridge, and it brewed itself. It also turned to vinegar fairly quickly, so you do have to watch that. But you don't even need to add yeast. Adding yeast is a benefit, and it does do fun stuff if you like add different kinds of yeast and all that. But anyway, so yeah, you can then stabilize it, and it makes it better, and then it can stay inside the containers and not turn to vinegar. Um, but my mhm, yeah, well, I mean, it was naturally the bacteria that's in the pineapple naturally just automatically break it down. Um, but you don't want to do that with honey because it doesn't really take bacteria all that well. Um, but yeah, then we switched to talking about some other stuff, and one of the guys was like, "Hey, you guys have to try this when you can actually legally buy stuff." Totally, wink, wink, nudge, nudge. Um, and he was like, "It's called ladies' bait," and we're like, "Oh God!" And all the people around the room go, "Oh, you're sharing that recipe." And he says you take a fifth of just the cheapest shit vodka that you can find on the market. And for us, it was 89 cents for a fifth. 89 cents. It was made down the street because it costs like practically nothing for them to make it. And they have a supplier who can give them the bottles for like 5 cents. uh, so they said, okay, you take a fifth of vodka and you pour it in a big jar, and you get like a gallon jug. You pour the fifth of vodka in, and then you take this is not against TOS, right? No, okay, we're good. This is educational. I can leave that tag up. Then you take a tenth, so like the little half bottles that are probably about that big, of um, it's a peppermint schnapps called Captain McGillicuddy's. No, that's true. Yeah, I'm not doing the drinking. Hopefully you aren't either. Um, so yeah, Captain McGillicuddy's. It comes in a glass bottle about this big, about that tall. It's basically a flask, and you pour that in, and then you take an entire bottle of well, not like excessive. You just don't tell me about it, and it doesn't matter. So no, I've had a beer on stream before. That doesn't matter. Nobody cares. It's as long as it's not excessive, right? Goods for nothing. How are you? You've just come into a sort of just chatting section of my stream. If you're interested in talking about mathematics, please let me know because yeah, it's like 750 mil. And then you get the 375 of the peppermint. And then you take an entire bottle of Hershey's chocolate syrup, or whatever your local equivalent is, and dump that all in. And then you shake it up. And you've got to shake it up for a long time. And a long time. Yeah, it's like a fifth of a gallon or something like that. I don't know. Shake it up for a long time. And then you put it in a closet and you forget about it for a while. And then every time you actually remember, you just shake it up and then put it back. And like after a month, maybe 3, you have this peppermint concoction. It's peppermint and chocolate, which is not safe for human consumption, quite frankly, in more than about this much. Um, yeah. So you mix it up, like I said, about once every time you think about it, and then yeah, you get this stuff and you pour it out in little tiny shot glasses, and you take little drinks at a time. I mixed it with eggnog, and it was quite wonderful. My father was very worried that I was going to become an alcoholic in like a day. So I never drank that much. I was always in control of it and very careful. Yes, we're talking about measurements. Okay. So interestingly enough, right? This so this is a bit of number theory here, which I kind of work on every so often when I'm just idle. Um, so welcome to the stream. My name is Obi-Wan Pez. This is N Simplex Pachinko, your hopefully future home for all sorts of math and interesting stuff. So Superbrain and I were talking about my history. Um, yeah, like I I know too many alcoholics, and so I cannot do that to myself. Um, over the past over the past yes, Colette's conjecture, nice. So I had yes, over the past couple of years, and this is in addition to, I guess, it's more like five. Over the past 5 years, I've had a degenerate condition where my gallbladder has been slowly deteriorating, and so I had it out last year, and it was like a month after I started streaming. Woo! I basically had like 3 sessions, and then I was like, so I'm going away for a while. I don't know when I'm going to be back. Um, yeah, that was not as much fun as I had hoped. No. Um, having the gallbladder out was actually not an issue. Uh, the recovery wasn't even a problem either. It was they did the um, endoscope thing or whatever, went in through the belly button and just kind of wormed the way up, and I have like three three incisions where they put cameras, which is really weird. Um, yeah. And then they made an incision in the belly button, took the excision tool all the way up, filled me up with nitrogen, I think, like blew me up with nitrogen like a balloon, and then fed it all the way up and snipped it a couple of times with the cauterizing thing, and then took it right out. And I was like, you did what now? Like they told me about it. It was just kind of like, hmm. Well, I mean, I was out, so like whatever. But I woke up and I'm like, meds are a good thing. Um, yes, that's also the other thing, is that it was getting significantly worse. And when they finally got it out, I got the grossing report from the gross lab. So this is not the we we learned the distinction here. This does not mean disgusting. This is actually a medical term, which is like they start cutting, they take out the thing, and then they start like cutting it up and doing like biopsies and other interesting stuff. So basically, they open up the gallbladder and it was like it's full of stones, and it's like velvety and fuzzy. I'm like, oh, okay, I'm done. Yeah, I'm much better now. Thank you. So I've had to be careful on like It's weird. So the guy, the doctor, the guy. So this doctor was like, so you can probably just keep eating whatever you've been eating because, like, your gallbladder not being there pretty much doesn't change anything. And I'm like, cool. Like, it wasn't working in the first place, so basically your body's just going to adjust. And, like, any fat that you eat is just going to pass. You don't have to worry about it. I'm like, that sounds not 100% correct, but, like, I'll just go with it. So, like, you know, it's fine. Whatever. But the thing that bothered me was that, like, my liver, right in here underneath the ribs, um, started feeling like not happy. And so I'm like, okay, if my liver's not happy, I shouldn't be drinking. So I just like basically cut out all. Yeah, it's not really a problem because again, like he said, pretty much nothing changed, right? Because it was already not working. So if it's not working, you know, whatever. Like he said, it was pretty much nothing changed. There was a little bit of a change, but whatever, it's fine. And then my liver starts hurting, and I'm like, okay, this is not cool. So I've tried like cutting out certain parts of my diet, and it's probably that I need to stop eating as much sugar and exercise more, and like that's it. But it's a pandemic, so nobody likes that. Besides, I stream. No. So the coughing is related to, at least I haven't had this like tested or whatever, but it's pretty obvious to me, the person who owns this body. Um, it's pretty obvious to me that it's like sinus drainage that just goes down the back of my throat, and it's making me like cough all the time, which is again pretty disgusting. But woo. Uh, so like when I was growing up, people were like, "Oh, you're..." Oops, that's not right. Well, it's just a nervous habit, or like, your coughing's related to this other thing, and I'm like, I don't think so. I think it's related to like not exactly allergies, but something similar to that, where it's just, yeah, it, it's just a pain. Like I'm actually coughing up stuff, if not, you know, whatever. We don't need to go there, but it's not bad, right? It's just you hear it all the time around you. People cough. Oh, that is reflux. Definitely that is reflux. Um, I mean, I'm not a medical expert and you should consult one, but from from the many people that I have heard from who have that same reaction, yeah, I'm I would be willing to bet money. So I think you should see a doctor about that. Which you can also test very easily by taking one of those over-the-counter ones. So, but yeah, I've had a lot of friends who have bad reflux problems. So, mm, yeah, some weird change inside your body which triggered this other thing. Yeah. Yeah. So goods. Usually, I call this my mandala. You know, you have people who occasionally will start coloring in pictures of, you know, whatever sort of stained glass or whatever. This is kind of what I do instead. Um, and sorry if you would prefer to be known by something else, let me know. So lately I've been going out to roughly 10,000 on every branch and then just figuring out a different one. Yeah, so still haven't finished my story. Um, yeah, so alcohol, right? Um, so I make this stuff, and my dad's like, "Oh my God, you are insane! Like you can't do this." I was 21 at the time when I actually made it, and I was like, "I'm fine. Okay, I'm having this much. I'm good." And he's like, "No, okay, I know it's hard liquor. It's fine." 120, huh? It's a real short list. So, yeah. Anyway, we're we're getting in the car after this brewery exhibition at this guy's house, showing off like how to make all the stuff and telling everybody like what the best yeasts are and all this stuff. So we get back in the car and it's just the two of us because our other friend who came with was driven by somebody else, and she sits down, buckles her seatbelt, and then leaves the car off. And I'm like, what? Because this is the girl that I dated for, like I said, 2 weeks. And she goes, "You know who you should date? My roommate." And I'm like, what? Like, never in my life had anyone even suggested that she was at all interested. It was just completely out of the blue. "You know who you should date? My roommate." And I'm like, really? And she's like, mm-hmm, hmm. Never really thought about that. And she was like, yep. And we just started talking about other stuff from that point on. But then, um, there were after this point, there were like sidelong and furtive glances, and then eventually I was just like, all right, screw it, and got up the unbelievable courage to ask out somebody who I was told was interested. And she was like, "Oh, yes, absolutely." And and then I find out years later that like find out years later she came back to her room and like laid on the bed and was like, her roommate's like, "What?" And she's like, "Yeah, this is back when we first met." Her roommate is like, "What?" She's like, "He likes Les Mis, he likes math, and he's got a girlfriend." And she's like, "Ah, sorry." So that's the inception of the entire our entire relationship was like this this girl that I dated for 2 weeks, her roommate, my current spouse's roommate, like my spouse's roommate, whom I dated for 2 weeks. I don't know if she forgot or if she just like I don't know what happened there. It's probably a story in and of itself that I don't know if I want to know. Um, but yeah, she was just like she knew about it. She knew about it from day one. No, I knew this, but this is the thing: is that like she knew that my spouse was interested from day one, and I don't know. Yeah. Now I knew none of this, mind you, right? Like none of it. So, so I'm interested in the roommate. Sure, why not? Oh man. Anyway, so yeah, I asked this uh, girl out the first time, and this was our toward the end of our sophomore year in college, um, and I was technically her RA. Short to state math problem. Go for it. Will it take 2 years and a doctorate to solve, or 10 years and a doctorate to solve? All right, JCM. Oh, well, he's still on. Oh. Single elimination tournament of 100 people. All right, so there's going to be 128 slots, but then you've got to have. No, that's fine. Yeah, okay. So this is going to be a 1/2 to the x problem. Here you've got 100 to start with, so you can figure out when it drops below integers. At that point, it's going to be a little interesting because you're going to need like wildcard slots to get them through. Um, well, it doesn't take long to get below an integer. I mean, like the next question, right? Yeah, it is. um, I mean, technically, it's half-life of one game, so every time you go one game, you're cutting the group in half. But then when you start having odd numbers of people, somebody's going to either get a buy, so they can immediately go to the next round just for free. How many games? Okay. Well, 8 rounds. Right, but how many games is a slightly different question. So yeah, the first round is going to be 50 games for 100 people. I think we still need a definition on how to deal with um, odd-numbered peoples. So do we give them a buy and say that that person just goes on to the next round automatically? No, no, I understand that. But we are saying like there are such a thing as buys in this particular case. So we're gonna get 12 on the next one, but then plus one person gets us 13 people, which means only 12 can actually play in that round. Which is going to get us 6, but then plus 1 is going to be 7, but only 6 can play. Uh-huh. This is going to be interesting. Right, that's what I'm asking. So this happens in this happened in our my son's playing a t-ball league, so like they're not actually keeping score or anything like that. They just play. But every team got a bye week where they don't play; they just rest at home, and every other uh, team pairs up to play. Because otherwise, someone would have to play twice, and that's potentially not fair. Which means that they're going to be half of that is going to be 3, but now plus 1 is going to give us 4. So now we're actually good. 2, 1. All right, so then games. It's going to be 50 here, 25 here. This can only actually play 12. This can only actually play 6. This can only actually play 3. And then we've got 2 and 1. So that should be it. 75, 80, 18 is 98, 99. Yep. In theory. Oh, right. Okay. So 1 game for every person who's eliminated. Right? There have to be 99 eliminations. There have to be 99 games. Touche. I guess I probably should have known that from the beginning. Good times. All right. I think that's going to do it for me. It's 1 o'clock here, so. Whee! Tonight, let's see. Yeah, so all I did was I did the checkbox to say that um, links are allowed to be posted. Yeah. Um, Before it was just doing stars for anybody, not just Pretzel. Just because at the beginning I didn't want to like allow, I don't know, I didn't want to allow random people to come in and just post links and random and whatever. Um, but it's good times. All right, so I think tonight let's go and raid. All right, let's go raid Buana. He's fun. So Buana is a streamer who recently finished a Infinistream, essentially. He did a streamathon that lasted until the new year, and yeah, Wow. It was it was pretty interesting. Goods for nothing. Thank you for the follow. I only just saw that. Sorry. um, all right, here we go. So thank you very much for coming. This is Obi-Wan Pez 4 and Simplex Pachinko. We're going to raid over to Buana. I will be back on Friday for more Talos Principle. Um, we're getting into the end game at this point. I am looking up a few things.